that we can write a plus b and a minus b. So we want to incorporate this into what we are doing now. Since this one is a square, this one is a square, and you have difference in between. So by so doing, I can now rewrite what you have here as, let me write the numerator first, 2mu square into 3mu minus 2u. That's the numerator. Then the denominator, I have my mu outside, then a complex bracket. Then I can now write 3m plus 2u into 3m minus 2u. So that is that's the application of difference of two squares there. Then if I move on, then I will have 2mu square into 3mu minus 2u. Then I'll have my mu into 3m plus 2u, 3m minus 2u. If you look at this very well, something is common to the numerator and denominator. Since this is the same for both numerator and denominator. Now from the top here, 2mu square is common to the two terms. So I brought out the 2mu square. Then here I'll be left with 3m minus 2u. That is the numerator. Then the denominator, I brought nu, which is a factor of both terms, out. Then I'll be left with 9m square minus 4u square. Then I still move on with the numerator remain the same. While the denominator, I realize that this one we can make it a square by saying 3 square, and this one also we can make it a square by saying 2 square. So automatically we have, since a square is affecting this and affecting this, we can bring 3m as an entity and let this square affect both. It is correct in mathematics. Then here we have this square is also affecting 2 and it's also affecting u. So automatically I can bring 2u as an entity and the square affected that way. And if I get to this point, recall difference of two squares, which states that a square minus b square is equal to a plus b into brackets into another a minus b into brackets. So automatically this one is by applying the difference of two square concept, then I can make this 3m plus 2u, then 3m minus 2u. And if you look at what you have here and the denominator, this resembles one of the denominator and this is the one it resembles. And in mathematics it's allowed that when the numerator and denominator are the same, they can cancel out. So I can cancel this and this. And remember that this one has a m, so I can cancel this m and cancel this m. Then this one you have u. This one is u square. I can cancel u and cancel 1u. You are left with 1u. So automatically, if I now want to rewrite what I have here, then I will have my overall result will now be 2u over 3m plus 2u. So that will be my overall result for the first case, which is number 1. Then the number 2, I have a square plus ax minus 6x squared over 2x squared plus ax minus a squared. If you look at these two expressions, you discover that these resemble this in a way, these resemble this in a way. So we can restructure the numerator so that it will look like the denominator. And by so doing, we have minus 6x squared plus ax plus a squared. Then we have 2x squared plus ax minus a squared. I want to solve the numerator and the denominator as an entity. Let me consider the numerator, which is minus 6x squared plus ax plus a squared. If I multiply this by this, I will have minus 6a, let me just say minus 6x squared, or let me say minus 6a squared x squared. Now, I want to look for two factors such that their product will be equal to this, and the addition or subtraction will give us the term in the middle. So, what are the factors of 6 that we have? We have 1 and 6, then we have 2 and 3. Which one will give us the one in the middle? It is basically this, and I can express it as minus 2ax plus 3ax. Minus 2ax plus 3ax will definitely give us plus ax. So these are the factors that will suit this particular expression. So anywhere I see ax, I want to replace it with minus 2ax plus 3ax. So I rewrite this equation, this expression rather, minus 6x squared minus 2ax plus 3ax. Then I write the last time plus a squared. Now I can dissect these two equations to the four terms as this. And when I do this, I try to look for a term that is common to both. 2 is common to this, then x is common. So I can factorize 2x out. Then I'll be left with minus 3x. Then this one will have minus a. Okay, there's a minus here, so I can move that minus out, such that when I move this minus out, automatically this one will be plus 3x. Then this one will be plus a. Then on this side, what is common here? A is common, so I can bring plus a out. Then I'll be left with 3x plus a. So if you look at this very well, you discover that this and this are the same. So I can decide to factorize that out, and if I do that, I will have 3x plus a, then minus 2x plus a. So this is what I will have, and this is all for what? The numerator. This is just the numerator. Let me denote it with num. Then the denominator now, which is 2x squared plus ax minus a squared. I will do the same. I will use it to multiply this. So I'll have plus 2a squared x squared. So what are the factors of 2 that will give us this one in the middle? The one that will give us this one in the middle. Can we get that? Then we have 1, okay, this is minus 2a, minus 2a, minus 2a squared x squared. So automatically I will have 2ax and minus ax. So this will be the factors that will give us the one in the middle, because 2ax minus ax will definitely give us plus ax. And when we multiply 2ax by minus ax, we have minus 2a squared x squared. So anywhere I see my plus ax, I will replace it with this. So here I will write the first term, which is 2x squared. Then the second term, that's the one I will replace with this. So I will have plus 2ax minus ax minus a squared. So what do I do next? We have 4 terms in this expression. We dissect it into 2. So we have this. We dissect it this way. So what is common to this? 2x is common. We bring it out. We have x plus a. What is common here is just minus a. Minus a is common. So this one will be left with x, and this one will be left with plus a. So since these are the same, so I can decide to factorize that. X plus a then gives 2x minus a. Let me call this done. Then. So my num and then will now be equal to, or implies that 3x plus a minus 2x plus a over x plus a 2x minus a. So that is what I'm going to have. And if you look at this very well, this one does not look like any one of these in any way. This one is similar to this, but I will make it such that it will be similar to it now. Let me bring it out. I have minus 2x plus a. This is what you have here. Then 3x plus a. I can rewrite this like this by the principle of commutative. So I can rewrite this as this. So automatically, when I bring minus out of this, I want to bring minus out of this, I'll be left with 2x minus a into 3x plus a over